Have you ever pondered the question, could the rise of artificial intelligence potentially widen the gap of social inequality? Today, we're diving into this complex issue, exploring the potential inequality issues brought by AI technology and discussing ways to mitigate them. Our journey begins with understanding the concept of data bias. Data bias refers to systematic tendencies in data collection, processing, or analysis that do not equally represent all groups or variables. This bias can stem from social, cultural, historical factors and can impact the accuracy and fairness of the decisions made by AI systems. In the realm of machine learning, data bias can have profound effects on the performance and fairness of models. Machine learning algorithms learn from historical data, and if this data is biased, the models can learn and amplify these biases, leading to unjust outcomes. Data bias can enter training datasets through sample selection bias, label bias, sampling bias, and data source bias. Next, we delve into the issue of algorithmic bias. This type of bias refers to the systematic prejudice in the results produced by algorithms during their design, implementation, or execution processes, leading to unequal or discriminatory outcomes. Algorithmic bias can reflect and amplify societal biases through the transmission of training data bias, feature selection and weight allocation, and insufficient model evaluation. Now that we've laid out the problems, let's move on to potential solutions. On the data level, the importance of cleaning and pre-processing data cannot be overstated. This involves detecting and correcting anomalies, missing data, and duplicates. Pre-processing includes standardizing, normalizing, and transforming features to improve model performance. Employing diverse and inclusive data collection methods, as well as advocating for open-source data and transparency, are also crucial steps in reducing data bias. On the algorithm level, the notion of fair machine learning algorithms is pivotal. These algorithms aim to ensure no bias or discrimination is introduced when dealing with different groups or individuals. Adjusting algorithm parameters to reduce bias can involve balancing datasets, masking sensitive features, and equalizing group error rates. Conducting algorithm audits and promoting transparency are also key to ensuring fairness. At the regulatory and policy level, the role of regulatory bodies in reducing inequality is significant. They can set fair standards for data usage and algorithm application, oversee and supervise tech practices of companies and organizations, and establish guiding principles for fair machine learning and AI ethics. Collaboration between the government and industry is also essential, involving joint research and development projects, training and education programs, and the establishment of a cooperative framework. Potential regulatory measures could include anti-discrimination laws, transparency regulations, and robust data privacy laws, all aimed at preventing unfair treatment of certain groups and ensuring the design and use of technology does not exacerbate social inequality. Looking forward, the development of AI technology will continue to advance towards higher levels of intelligence, wide integration, enhanced natural language processing, and integration with edge computing and the Internet of Things. But this development requires more than just innovations and expertise in the tech field. It calls for a collective societal effort, cross-disciplinary collaboration, public participation, education and training, open data, and transparency. By working together, we can guide the development of AI technology towards a more sustainable, inclusive, and human welfare-oriented direction. Remember, the future of AI depends on our collective actions today. Let's strive for a future where AI serves as a tool for promoting equality, not exacerbating it.